Structure is the set of rules and relationships that organize raw facts into meaningful, usable data. Without structure, data is a pile of disconnected values. With structure, it becomes a model of reality. A useful metaphor is the blueprint of a building. Structure defines where the rooms are, how they connect, and which materials are allowed. It gives purpose to raw bricks and beams. So what exactly do we mean by data structure in practical terms? Data structure refers to the schema, formats, constraints, and relationships that determine how individual pieces of information are represented and how they relate to one another. At the simplest level, structure specifies fields, types, and units. For example, that a dataset has a date column, stored as an ISO timestamp, and a price column, stored as a decimal in euros. At a deeper level, structure embodies relationships. One table references another, a document nests sub-documents, or a graph expresses links between entities. Structure also includes rules, uniqueness constraints, foreign key relationships, required fields, and validation logic that enforce consistency. Why does structure matter? Because structure determines what questions you can ask of data, how efficiently you can answer them, and how reliably those answers reflect reality. Structure impacts storage, indexing, query performance, update semantics, and the ability to evolve systems without breaking consumers. Now let's look at how structure is expressed across common data models. Relational structure models data as tables with rows and columns, relying on keys and joins to express relationships. Document structure stores nested JSON or XML objects, where related information may live inside the same record for fast retrieval. Graph structure models entities as nodes and relationships as edges, which is powerful for connected data like social networks or dependency graphs. Key value and wide column structures prioritize simple lookups or sparse attributes, which is useful at extreme scale. Each model encodes different trade-offs between normalization, query patterns, and write-read performance. How is structure designed in practice? Data modeling begins with understanding the domain, the entities, the relationships, the invariants, and the operations that matter. Designers capture this understanding in schemas, ER diagrams, JSON schemas, or protocol definitions that become the machine-readable contract for producers and consumers. Good structure codifies assumptions explicitly. For instance, whether a field is optional, which units are used, or whether values are normalized. Structure also anticipates scale and failure modes. Indexing strategy, partition keys, and transactional boundaries are all structural decisions. Why do structural choices matter for downstream work like analytics and machine learning? Because structure shapes data quality. Clear types and constraints reduce ambiguity and enable automated validation, which means fewer surprises in analysis. Structure influences feature engineering. Nested documents may need flattening, categorical encodings require mapping, and time series alignment depends on timestamp resolution. Structure affects interpretability. A well-structured dataset carries metadata and context that help analysts understand provenance and semantics. What are the key features of robust data structure? First, explicitness. Types, units, and semantics should be encoded and documented. Second, consistency. Conventions should be applied uniformly across datasets to preserve comparability. Third, evolvability. The structure should support schema evolution through versioning, backward compatibility, or tolerant parsers. Fourth, validation. Automated checks, constraints, and tests ensure that data conforms to its declared structure. Fifth, discoverability. Schema registries, catalogs, and clear naming conventions make structure accessible to teams. What are the common structural mistakes and their implications? Implicit assumptions, such as unstated units or overloaded fields, create ambiguity and integration friction. Over-normalization can hinder performance by requiring expensive joins, while under-normalization can introduce duplication and update anomalies. Inconsistent naming and ad hoc fields produce brittle ETL pipelines and slow down onboarding of new analysts. Poorly versioned schemas lead to silent errors when producers and consumers diverge. What are the practical strategies to design and maintain good structure? Start with domain modeling. Interview stakeholders and document entities, attributes, and relationships. Define canonical schemas and publish them in a registry or contract repository. Use strong typing and units wherever possible and apply validation at ingestion points. Adopt schema evolution patterns such as additive changes, feature toggles, and migration plans for breaking changes. Automate compatibility checks and include structural tests in CI pipelines. Monitor structural drift over time by tracking schema changes, field usage, and validation failure rates. Document intent and provenance. Explain why fields exist, how they were measured, and what assumptions were made. How does structure relate to governance and trust? Structure is the backbone of data governance because it encodes the rules for access, lineage, and quality. Clear structure supports audits, compliance reporting, and reproducible analyses, all critical for regulated environments. Finally, what are the implications of neglecting structure? Neglected structure leads to integration failures, incorrect analyses, slow development cycles, and loss of institutional knowledge. Conversely, investing in structure yields faster analytic velocity, more reliable systems, and clearer accountability. In short, structure transforms raw data into a coherent, queryable, and trustable asset. When you design structure intentionally, you make future work easier, safer, and more truthful. And when you inherit poorly structured data, your first priority should be to document assumptions and introduce lightweight structure gradually. Structure is not a one-time artifact, it is a living contract between systems and the people who rely on them. Treat that contract with care, and your data will repay you many times over.